Today's topic is our arrays and memories. So we will understand how to implement arrays and memories. And before that, if you want to understand like packed array and packed array, most famous question in interviews, so I have already created that video. So mostly we will focus on how to implement these arrays, how we are using these arrays. Okay, so first question is what is arrays or Verilog array? Okay, we are only focusing on Verilog array. Okay, so dynamic array and associative array we will cover in SystemVerilog course. Now, an array declaration of net and variable. So first of all, net is your driving element, driving data type, and variable is our storing data type. Okay, so both we can use for array. Can be either scalar or vector. Scalar has a simple scalar like a register if you are creating with some memory, so it is scalar, and vector is like 2D array or something with having a depth or a height or something. Okay, now any number of dimension can be created by specifying an address range after an identifier name is called multidimensional array. So for example, if you are creating memory, because mostly you are creating memory, right? So in your industry, if you are going to work, you will create a memory, or you will check that memory. Someone has created a memory and you will check that memory. So you can have multiple range. A Verilog you don't have any limits for range, you can say. Only limit is that what your tool you are using which has a limit. For example, if you are using unpaid tool like QuestaSim or that EDA playground or something, it has some range, but in real industry tool there is no range. You can create a multi-bit array, so that is called multidimensional array without range. Now, how to declare that array? So declaration is simple, or y is element is to 0, you say that. So first your data type will come, then your name of that name of that array will come, and then you will declare that. This is a scalar because it don't have any direction or anything. You can say just a single array. You can say normal array, unpacked array. It is unpacked array. Okay, so a packed array has the same thing will be written in this side of the y1. So that will be packed array. So here it is called depth. So whatever you want to call, you can call depth or width or anything. Now, second, this is our variable data type, and this is our net data type. So you can also create with both of them. Now here 8-bit is vector, means we will store in this, and this is our depth. So simply you can say like there will be 4 arrays. Okay, here, and this is 0 to 7, and this is 0 to 3 to 0. If here it will be 0 to 3, then it will be 0 to 3. Now, so something like this we are creating 8-bit vector net with depth of 4. Now this is our 2D array. Now same thing is here, your first data type will come, then your name of the array will come, and how you will write this I will explain this after after this slide. Okay, so array assignment, how to assign this. So first of all, this is illegal type like y1 equal to 0, because it is array, you have to specify some index for that. Okay, so this is the common thing. This is all element can be assigned a single go, we cannot do that because we are doing hardware coding. But in fact there is some exceptional cases are there, you can watch my video for that. Now what is the legal thing is like y2 0 index and 8-bit you have assigned. Okay, same other thing you have done with the second index, same array y2, y3 you have used multiple index for that, and you have assigned 8-bit. Now as I have said, I will explain you how to understand how the arrays are creating. Okay, so first of all you can understand here n is your number of array, okay, and w is your width, and you can say length, we will take length or height, width or depth, anything. Okay, these 3 things we need. this is array, this is one number of width, this is length, and this is one number of array. Okay. Now for example, if you have given some n equal to 2 and l equal to 2, so array will be like this will be of 2 bit and this will be of 2 bit. Okay, so this length is 2 bit 0 to 2 or 2, so I will take 1 0 to 1 0 to 1, okay, 0 to 1, okay, 0 to 1 it will be, and this 1 is written for this 0 and this 1. Okay, so this is number, how many number of L is there? So number 2, and what is width of that is our 0 to 1. Fine. Now if you have given this as a 1, so it will first consider your width. Okay, so the array will be like this, box will be created, or you can say 2D array. So here your box is like this. So first these two will have your, so it will be like 0 1 0 1 0 1 0 1. So this 2 is taken care, and now this one, the number is 2 0 and 1. If you have created a whole, you have given 1, okay, like n equal to 1, w equal to 1, okay, I will write again, a is here, 0 is to 1, 0 is to 1, 0 is to 1, 0 is to 1. Okay, so this thing you have given. So there will be 4 boxes now. First we will take care of this, 0 is to 1, 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 0 is to 1.
Hit subscribe, like, and comment now. Let's begin the journey of verification.
So now this one is number 0 1 and this one is our number 0 and 1. So this kind of thing is there. I hope you understand with my messy writing. Now another thing is like 1 bit equal to 1 flop. So you have to understand 1 bit is equal to 1 flop. So whatever you are creating bits, you are creating 1 flop or latch, but mostly flop. You have to understand this thing. Now, so array example. So we have created some module of this name, and we have created one memory of this, second is this, and third is this. Okay, and I have already told how to initialize this. So we will just have 8 bit here, okay, and we will display this. Okay, so this is vector 8 bit and 8 bit byte vector, where I have explained all the 3 categories. Now int I will explain in next slide. Okay, it is just initialization of I as a variable, and now memory has our 8 bit, and here our 8 bit hexagon. Okay, hexagon code. Now our display, we will display this whatever the number is there in initial begin block. Now next thing is the memory number 2. We are giving this initializing with some value here. We are giving that value after declaration. We have given some value, and that I have used before this variable with the for loop. I am just displaying that whatever inside that memory. Third is your third array, but for now we are using 2 for loop. First for assigning, means both are for assigning and both are for display. Okay, so we are doing display and assignment at the same time. So I plus j, whatever value is coming, we will just giving this memory value. Okay, in this way you can give memory a value, and you can create some memories like this one. Okay, and yeah, so whatever question you have, you can comment me, and thank you for watching.
Please, Lord, give me a sign, a sign.